Welcome to episode 7 of the More XR podcast. It's the latest in augmented reality to virtual reality and everything in between, and it's brought to you by More Insights and Strategy. I'm Anshel Sag, More Insights and Strategy Principal Analyst, covering XR, 5G, smartphones, PC, cloud gaming, and much more. And this week we have Johan Hellqvist, VP and Head of XR at Tobii, to participate in a discussion about bringing eye tracking to the consumer market. Thanks very much for joining us, Johan.
Thank you very much, Anshel. Great to be here again.
And I wanted to kick off this discussion kind of as a starter, talking about how Tobii is arguably one of the most knowledgeable companies when it comes to eye tracking. And if you could tell us possibly, what the different ways are that Tobii supports eye tracking today.
Yeah, it's a good question, because normally we talk about use cases and what you need eye tracking for. But if you put that aside, beyond that, we also do support use case development. So we have a dev zone where we have use case code example and libraries that can be downloaded for free. We also see when we have different devices, XR is pretty heterogeneous. So we do different eye trackers for different devices, and now we have started to launch with pancake and folded optics design, and also true glasses type of AR form factors. That's one very important part, which is core to us. Another one is kind of how do you get access to eye tracking. So we've been driving the standardization of eye tracking in OpenXR. So there is a standard of gaze tracking right now. We're taking the next step to standardize how you do foveation for foveated rendering. We also work with partners like NVIDIA and Qualcomm. We've done a lot of foveated rendering. Lastly, the last thing we did was with NVIDIA, enabling VRSS2, which is the first time that you can actually get foveated rendering without actually changing anything in the application. It's a driver level, which is a huge thing for eye tracking and foveated rendering. Another thing is that we also work with ISVs and game studios to kind of help them and provide hero features, and that we then kind of co-market with the OEMs and partners. And on top of the core eye tracking part, we also have additional middleware software for advanced analytics that we sell on top of our eye tracking offerings for high-end medical and ISVs applications. And then we also have the portion of transparency and privacy. So we're driving transparency policies, since eye tracking is very powerful, into our contracts, but also kind of advocating for it in the industry. So I mean, it's since you're market leader, you need to do a lot of things.
Yeah, I was going to say it's a lot more than just providing the hardware and an SDK. I guess since eye tracking is becoming more mainstream as part of the adoption of VR and AR headsets, what are some of the consumer-driven applications of eye tracking compared to maybe what we're hearing on the enterprise side?
Yeah, so one kind of the silver bullet since a long time is foveated rendering, and that is one that will drive consumer eye tracking as well. But beyond kind of that part, which is kind of relatively known, I think the main benefit for the device itself is that eye tracking can enhance and make it easier to navigate and make it more natural to use your hand controllers. Eye tracking is all about giving and knowing the user's attention. And if you know where the user is looking, then you can act on what the user is looking. So that's super good when it comes to combining hand controllers or even gestures, and not to replace them, but to enhance them. The other part is kind of the current name of the game or hype right now, the metaverse, where it's a lot about social interaction. And one very, very important aspect is, of course, where I'm looking. Am I looking at your mouth? Am I looking at your eyes? Or am I looking further down? That has different meanings when you communicate. And that's what eye tracking gives, apart from the animation part of your eyes. So I think that's something that will be more and more important. Another part that is part of the device is you can use eye tracking to kind of enhance where you have the objects in space. So you can adopt any parallax differences from where you have your IPD on the device, whereas you have them in the reality. So when you start interacting with objects in a more natural way, that will become more and more important. And then, of course, for consumers, a lot of what's going on now is gameplay. The entrance of eye tracking into gaming will have a tremendous impact. And we have a couple of examples on our end. It could be selecting with your eyes. If you're throwing something, for example, you don't know how heavy it is because you have a hand controller. So using your eyes to augment where you're throwing, for example, is one of the very, very good examples. Or if you're in pursuit, it's very difficult to pursue with your head or with game controllers, especially if you're using the controllers, and having eye tracking assist that part of the gameplay, we think would be very important. And of course, once the studios starts working with eye tracking for real, then there will be tons of different other use cases.
And on that topic, as a follow-up, I was kind of curious, do you see eye tracking being a popular user interface in addition to, right now, if there is no hand tracking or controller, people use gaze, right? But it's usually just a head pose. It's not really a gaze.
No, that's. I mean, if you have controllerless, you use your head and right now, but we've seen that if you use your eyes instead, I mean, that's what you do in your everyday life. You don't point around with your head, and the natural part is just look at something, and then you can have a click or a dwell. I mean, we've been working with assistive devices for 20 years, and there we use dwell for people who can't move, which is sufficient. For people who can move, it's better to actually have a click or something subtle or a small gesture or a click on the headset. So for leisure gameplay or for leisure usages where you don't have eye tracking, or for sure also in AR eventually, then gaze will be super important, because how do you give intent if you don't know where you're looking? You don't want to have a pointer in your AR glasses and looking around. You just want to look at things and say, what is that? I think that those simple natural use cases that we take for granted in the real world, we have to translate into the 3D world as well.
Okay. And one of the big discussions around eye tracking, both in the enterprise and in consumer, but I think consumers are much more sensitive about this, is do you see eye tracking as an additional layer of security? Because right now someone can just grab a headset and put it on, and the only layer of security that exists today is put in a pin if you're buying something. But long term, do you see eye tracking as a security feature?
I think yes and no. I mean, eye tracking is kind of deciding where you're looking, but based from the eye tracking system, you can decide what kind of user it is. And the easiest example is actually just not necessarily security, but convenience. Is this the same or a different user since last time, and then loading the right profile. So that's kind of the entry level of use case, just to have it more convenient, which I think is maybe in this kind even more important. The next step is with an eye tracking system, you can do biometric ID, but then you need to pay attention to how you treat that data, so you have that in a secure way, that you terminate images as soon as possible in the device. So we never give access to anything beyond the computed signals, like there's no images or so, that's always just terminated. So I think that will be, or is very important. So yes, eye tracking can provide additional value when it comes to both profile management and security.
Okay. And we talked about this a bit, but how do you see, eye tracking in consumer products specifically evolving from where it is today? Because today it's very early, and the use cases are pretty simple. But are there use cases down the road that maybe will change over time?
I think if we look on what will change over time beyond the use cases, is also how eye tracking will change over time, and have changed over time. For a couple of years ago, eye tracking was for researchers primarily, and then then we moved into deploying eye tracking in mass or in full production volume in the enterprise where we are now. Then all the use cases from simulation and training, remote training, medical applications has been evolved. But on top of that, we also need to spread how many can use eye tracking. So we kind of focus a lot on having population coverage and ease of use. That will be even more important when we move into consumer, where you can't have that it worked for some and for some not. So and that's kind of the next level of eye tracking that is coming now basically, and we have the capabilities from that perspective already. When it comes to new user application, it will be the good ones that we've seen in enterprise. They will be very much present in consumer as well. But then there will be the added, like we talked about a little bit just on the previous question, on interaction between users, interaction between the device, interaction within the application. And I think when you come to augmented reality eventually, that will be even more so, because there you need to relate to the real world as well as the augmented world, and then eye tracking can kind of bridge that portion quite a lot.
Interesting. So you see in AR at least eye tracking being the HMI between the virtual world and the real world, because people are they're not going to have a mouse, they're not going to have a controller in a lot of situations.
Yeah, I think it will be a combination. I mean, in AR, I think gestures will be important, but you don't want to wave around kind of like a lunatic. You want to do subtle gestures, small gestures, or even click. There's click rings, for example.
Right.
Just looking somewhere, and you do a small manipulation of where you're looking instead of reaching out, or if you're doing something that is beyond your reach, then eye tracking will be essential, because you can't go around with hand controllers in AR. And I think what we've seen in the enterprise is that some users are pretty are not accustomed to hand controllers, and it's odd. And there we've seen a bigger demand of actually also in VR using VR without hand controllers. So as long as you are kind of having controllers that are less and less complex, the more you need eye tracking to give focus. What the hell are you? What do you want to do?
Right.
That's easy to decide when you know where they're looking, but it can be very tricky otherwise.
And do you see like a combination of, like, for example, I'm thinking of mixed reality applications where like the Lynx headset, where you have hand tracking, right? So maybe you combine hand tracking with eye tracking, so like there's a whole menu on your hand, and based on which finger you're looking at, you can decide which menu option to choose.
Yeah, I mean, absolutely. I think gesture and eye tracking is a perfect combo. But because the problem with gesture is that you need to give context on what I'm trying to operate towards. And that context is what eye tracking gives. And you can also select with eye tracking. So if you have a complex environment for gestures, that need to be very complex gesture tracking. But eye tracking can make that much easier, because then you get the context and you know the user's attention, and then you can have easier gestures that ultimately will save power. So not only kind of complexity for the user, but also for power, because you need less compute to do these complex manipulations.
Okay, yeah, that makes sense. To follow up on one of the things that you said earlier, I was kind of curious about the idea of broadening the types of users that can access eye tracking. What are you guys doing in the space to make that more accessible? Because it sounds like you're saying that there's a certain number of users that aren't going to be compatible today. What are you guys doing to make it more compatible with more users?
That's the only thing we do today. so I think so we have taken tremendous steps. Right now we are at the point where we track the full population. Everyone, we can track everyone basically, unless you have eye diseases or real physical problems with your eyes. One other aspect of the eye tracking is the performance differs over a population. So if you want, especially consumer, if you want to design a graphical user interface or interaction, you need to design it towards some metrics, some separation of object distances, etc. And for that, we've made quite a big leap, both in standardization, but also to educate the market how you do measure eye tracking. And what we're working on is not to improve the performance for the very best or nicest looking people from an eye tracker perspective, but from the last quantile, the worst performance. That's where we put our effort into make them as good as possible, because they are the one driving what you can do with eye tracking. When it comes to foveation, then you can adapt the foveation or compression ratio depending on your individual eye tracking performance. But when it comes to user interaction, you can't. Then you need to have a uniform experience. You can't have one experience for some and another one for other people. So that is what we work with the most, and that we have major breakthroughs during the last years.
And when you optimize for the worst case scenario, it also improves the best case scenario as well, right?
Yeah, a little bit, but I don't care, to be honest, because I rather trade a little bit worse peak performance for some better performance on the worst performing parts, and it's kind of, for us, it becomes the main objective for us is to make it as even as possible. You don't want to have one experience for one person and a different experience for another one. That you can have in research for sure. You can have that to a certain extent in enterprise, but in consumer you can't. And that's where we believe that we excel, in combination with, if you take the headset off and put it on, it needs to work without calibration or anything. It's just, or if it slips a little bit, it needs to be, and that's the consumer grade. Consumer is actually the absolute most difficult, because they do lots of strange stuff and it's uncontrolled, and our experience in that makes us, we know that we can do it. So that is the major big difference from going from enterprise to consumer.
So I guess, as a follow-up to that, I'm kind of curious as to what might be challenges, other than being able to support so many different types of users. What other challenges do you encounter in consumer that you maybe don't encounter in enterprise and in research?
I think power consumption is another thing, where if you have, but that's of course as applicable in some examples in enterprises. But if you, for example, if you have a standalone headset, you do want to have as much battery time as possible. And if you just pull together a humongously big neural network and do eye tracking, consuming all resources in the headset, it will just die in 5 minutes.
Right.
So we have kind of optimized, and we are running a mixed model. So we actually save power if you run the headset with foveated rendering.
Right.
So not only, so that's kind of an added benefit for the battery. So that is one of the things that is super important for consumers. Another one that is a little bit more futuristic is you can also use foveation to compress when data is transferred from, for example, a cloud server to a 5G connected headset in the future. And then saving bandwidth is saving money for either the telecom provider or for the user. So those non-interactive use cases will be very important for consumer as well.
Okay, that makes sense. I thought about the whole idea of consumers and their devices, and now that I think about it, I always forget how much power savings you can do with foveated rendering, and it compensates for whatever power consumption occurs in doing the eye tracking. But to your point, eye tracking has to be on all the time. So
yeah, absolutely.
Power is super important.
Yeah, and another one in AR is, for example, if you want to detect what's happening around you, You have front-facing cameras doing detection on if you look on a menu, you may want to translate it. You look on a sign, you may want to know what that is. You look at on something, what is that? If you don't know where the user is looking, you will do loads of calculations. So we call it foveated AI, can only calculate on AI or in recognition where you're actually looking. That will also save huge amount of compute power. Another thing that is important for consumer right now, we see a range of new type of headsets coming out. So folded optics, for example, will give the VR much lighter. They have great visuals. And that would require a slightly different eye tracking approach than what we had before.
Right.
That is now a platform that we have launched. So we support pancake folded optics, the same architecture you can actually use for glasses, kind of looking AR devices. It's the same application, and now the components are so small so you can fit them in the normal pair of glasses. So I think that is kind of the other aspect that is super important for consumers, is it has to look good. You can't look like a dork. Well, you can, but not the average Joe. You and I maybe want to look like dorks, but since we love XR so much, but the average Joe won't.
That's a good point. Yeah, and I think miniaturization is a constant trend, right? But I guess another thing when OEMs are designing is, cost, right? What is going down with the cost of eye tracking today versus where it was, say, 5 years ago?
Yeah, it's a good question because cost has many aspects. We, for example, at Tobii, we use an approach where we can use standard components. So you don't need kind of tailored or special components. We follow the kind of the standard CMOS trending sensors and compute, which kind of optics doesn't follow Moore's law really, but it kind of at least becomes more much cheaper depending on volume. And if you use standard components, those components will go down in price as they go up in volume, regardless of what Tobii does. So that's one aspect. We also reduce the number of components. So before we had to have 2 cameras per eye, we only have 1 camera per eye or sensor per eye. We also have a easier way to mount components, so it's cheaper to manufacture. And then we've done it a lot of times. So just doing a mass market and a volume deployment once is quite costly. The second one a little bit cheaper, and so on. So we've kind of been there, done that in a way. So we are pretty confident that eye tracking will. Yeah, it's one of the subsystems. The boom is less than $10, so it's not a huge investment, given that we actually also save power. So.
Right. Yeah, and I will say that I've seen eye tracking prevalence in 2020 was okay. There were some early implementations, but 2021 was just one after another, and it feels like that momentum's probably going to continue into 2022. And as we get into 2022, which sounds like it's going to be a very big year for a lot of reasons, I wanted to talk about the privacy side of things, which I think you touched on a little bit there. But I wanted to get a little bit more clarity about how does Tobii handle biometric data? Who has access to that data? And also, maybe you can speak to what's going on in OpenXR around privacy and give some details on that.
Yeah, so I mean, eye tracking is super powerful. Knowing where the user is looking is of course is very, very important data, not only for interaction, but you can do analytics on it. And that's, you need to be very careful towards the user. So we're driving something we call data transparency policy, which we have in all our contracts with all the OEMs, where you as a developer for a specific headset, you need to ensure that if you store the user's eye tracking where they've been looking, or transfer the data, you need to alert the user that I'm doing this. Are you okay with it? It's kind of in line with general transparency implementations that is happening in a lot of smartphones and in general. And I know it's a big topic of the big OEMs. So that's one side of the things, how to safe haven the output from the eye track. And then when it comes to the biometric data in terms of images and the raw sensor data, basically, that is terminated down, very far down. So we don't have open interfaces for eye images, for example, and that's also something that we both do contractually, but also by design. And in OpenXR, there's no plan to drive more images or anything like that, raw data from any eye tracker. So that's something that is kind of blocked in OpenXR. When it comes to industrial engagements, we have, for example, at the last AR/VR association event, we have our CEO Henrik Eskilsson had a speech about privacy and transparency and eye tracking. So we're driving that together with the industry to ensure that the eye tracking data is treated properly. This is, of course, not only eye tracking; it can be any kind of sensor data that comes from other aspects as well. So we drive eye tracking, but from a bigger picture, the transparency part when it comes to using also AI and kind of harvesting different type of sensors that's need to be managed on top of what we do.
Yeah, and I guess the other question I have is, since that sensor data isn't being accessed by anything and doesn't really have a path outward, are there some forms of encryption that are occurring to protect that data? I'm kind of curious because, it sounds like you guys have done a good job of keeping it out of people's hands. But is it also encrypted as well, or does it sit in an encrypted method?
I mean, you need to encrypt if you send it over kind of a wire or where you can access or sniff it. Our strategy is to not send anything over wire or to be able to sniff it. So we terminate it as deep down in the silicon as possible.
Okay.
So that is the approach. We don't, for example, send any raw sensor data from the device to a host to do eye tracking computation on a host. We always terminate it at the device, as close to the sensors as possible. So if we weren't, then we absolutely would need to encrypt. But we don't encrypt unless we send data out of the silicon, so to say, or out of the safe zone of the silicon.
Okay, and that sounds like a form of best practices when it comes to eye tracking and privacy. Are there any other best practices you guys are doing when it comes to eye tracking, privacy, and security?
It's the data and transparency policy, which is more treating the processed data, and then we don't have a developer for an OEM device never have access to any images.
Okay, perfect. And I guess, now that we've covered the difficult topic of privacy and security, do you think that there's a time frame when we can expect to see eye tracking in consumer headsets, considering the fact that we are, we have tons of them in enterprise headsets today, but the consumer headset seems to be the next step?
Yeah, and we believe it will be next year.
Wow, that's very soon. I'm very excited to hear that. And I guess, to kind of wrap things up, was there anything else that you think that people should know when it comes to eye tracking, specifically for consumer, or even eye tracking in general that maybe might be a common misconception, or something that you'd like to talk about?
I think one last thing is if any developer is listening, especially consumer application or game developers, eye tracking will be deployed, we think, next year. And there are devices right now that you can start developing consumer applications. I mean, there's Pico Neo 3, there's HP Omnicept Edition, there's HTC Vive. So I think that's kind of a call for action for you guys, that if you are believers in eye tracking, it will be around very soon in consumer headsets as well. And a lot of things is also happening on the AR side. It will not consume for next year, but right now you can actually build decent AR headsets with more or less existing subsystems. So that's also something that has been very a very big change the last year. But VR is going consumer with respect to eye tracking for sure.
Great, that's very helpful, and now people know exactly which headsets to get if they want to get down into developing eye tracking in VR.
Yes.
Awesome. Well, that kind of wraps up our discussion around consumer eye tracking. I want to say thank you very much for joining us. And we hope our viewers and listeners found this week's topics interesting. If anyone out there would like to provide insights on a specific XR topic for future podcasts, please reach out to me on social media. I'm at Anshel Sag on Twitter. I want to say thank you very much again to Johan and Tobii for joining us this week. And we hope you have a great weekend, and please tune in again next time.
Thank you.
Thanks a lot.